Hi guys, so in this lecture we'll be continuing our discussion on acidic strength. So how does a plus M plus H plus I or minus M minus H minus I have impact on acidic strength of organic compounds? We'll be discussing that in this lecture. Okay, so let me start off with a compound. Let us say I have some compound. I have some compound which is attached to on which we have acid um, carboxylic acid attached. So now what I can say that if that group is minus M group, okay, minus M minus H or minus I group, then actually if I have something like this, then it is good for my acidic strength. But if on the other hand, if I have plus M plus H or plus I on this compound, then it would be less stable, as more electron density would be there on this, which will result in electron repulsion, hence less acidic strength. So I can say that acidic strength in organic compounds is directly proportional to minus M minus H minus I groups attached to the proton giving group, like in this case this one, while as acidic strength is inversely proportional to plus M plus H or plus I. So please remember this as a rule of thumb, and you won't face any problem when you need to compare or have a comparison between acidic strength of two or more organic compounds. So with that being said, I'll just show you some of the examples of the same. Okay, so we have this and this. Okay, so what is the order of acidic strength as we go? What is the order of acidic strength as we go down the list? So if you want to check what is the order of acidic strength, we just listed out the formula that the order of acidic strength is inversely proportional to the plus M plus H or plus I groups attached to this uh, carboxylic acid group. So as we go down, the acidic strength should decrease. Why? Because plus I increases. When we make conjugate base, so just make the conjugate bases of each of the compound and you will know that the acidic strength decreases. Okay, so now let's look into more examples. We have we have CHCl3 and CHF3. So what would be the order of acidic strength? This is more than this. Why? Because in the conjugate base we are seeing that C has 3 chlorine attached to it, and in this case it has 3 fluorine attached to it. It's a conjugate base, so I should write minus sign here. Okay, so in this case d orbital resonance can take place between C and Cl because it is having vacant d orbital, which is not the case in this compound. Okay, hence acidic strength is greater for this compound. right? So just remember the form that more stable the conjugate base, uh, more is the rate of reaction forward. More is the reaction in forward direction. Okay. Okay, so just remember the form fact that phenol is more acidic than alcohol. Why? Because if you look at phenol's conjugate base, it is O minus. Okay, and if you look at the conjugate base of alcohol, it is O minus. This is the conjugate base, this is the conjugate base. Okay, so in this case the O minus is attached to a minus M group, hence the electrons will be floating around in the ring. Okay, hence it is a more stable compound. This implies that the acidic strength of phenol is greater than acidic strength of alcohol. Let us look into this example wherein we have something like this. We need to compare the acidic strength of this with acidic strength of this. This is an important example. So we got to know that the acidic strength of ketone is greater than the acidic strength of ester. Why? Because in the conjugate base, if you just see that this is here and this pi electrons are involved in resonance, as you can see here. So this acts as a minus M group. It increases the acidic strength. But if you look at this group is actually busy in its own resonance. It is not at all bothered with having resonance with this pi electron, right? So this is not a minus M group. It is a very mild minus M group because it is involved in its own business of creating resonating structures from the lone pair of electrons on oxygen atom. Hence, due to we can write that due to no resonance. By resonance I means external in case of ester, it leads to less delocalization of pi electrons on C minus group, C minus atom, hence less acidic strength. Okay, and why? Because ester group is involved with internal resonance. Okay, hence this is more acidic than this. Okay, so also let me write that alpha hydrogen of ketone is more acidic than alpha hydrogen of ester, as ester's conjugate base is less stable as it don't involved in resonance with other groups. Okay, so just for a matter of documentation I'm just writing it, or just for the sake of writing. I hope the thing is already clear in your mind. Alpha hydrogen of ketone is more acidic than alpha hydrogen of ester, as ester's conjugate base is less stable due to no involvement of ester in resonance with other groups. Okay, and on a matter of fact, some scientists actually experimented the resonance energy in this compound and this compound, which they found that the resonance energy was nearly equal. For this case it was minus 78, and for this case it was also roughly minus 78. Hence the ester group is too busy with itself, having resonance between itself only. Okay, so with this we end this lecture. From the next lecture we'll be seeing more details on acidic strength of organic compounds.